Good morning, everyone. At least for me, it's morning. I wanted to introduce you to today's topic, troubleshooting PHP issues, best and worst techniques. Actually, probably not worst techniques. I would say not so good techniques is probably a better title for today's presentation. My name is Ed Kitlinski. I'm a Zen Solutions consultant here. I've been here for about 3 years. And I'm going to go through some of the agenda here. Let me go to the next slide. A little bit of housekeeping first, though. I just want to let everyone know if you could mute your phones, it'll keep the noise down. We're definitely going to do Q&A session at the end. So if you have questions, start typing them in to the chat session on the right-hand side. Again, I'll take those at the end. And we are doing a recording, as you heard earlier. So if one of your peers wants to take a look at this presentation and you want to share it with someone, you definitely can email a link. Okay, so wanted to start by welcoming everyone. Judging from the turnout today, many of you already appreciate the importance of good troubleshooting practices and how they positively affect your PHP projects. But what you may not know is how important it is to do this as early as possible. In a study that you're looking at right now by Bohm and Papacchio about code quality and how it affects developer time and cost, the graph shows how the longer a defect remains undetected, the more expensive it becomes to correct. So that seems pretty much like common sense, but the analytics behind it have been published in this report, and again, depending on the technology the developer uses, the costs and obviously time is adjusted on the graph. So the saving potential for early bug detection is pretty huge. They were talking about how IBM found that its most successful projects still had about 5% bugs outstanding, even going into production. So that's from really the top ones that they analyzed that year, the year of the study. But typical projects actually have a higher bug percentage, and IBM found that the higher percentage of bugs that make it into production, the higher probability that the projects will fail. So the goal is really, it's an obvious goal, is to eliminate all known bugs during QA. And we should expect a certain amount to make it into production because, again, it's difficult to identify all bugs early in development and QA. So in the study, it was also found that a decision early in the project to postpone troubleshooting and testing, testing and correcting bugs until later in the project, somehow the project manager thought it would save time, but it actually results in more expensive and time-consuming troubleshooting workloads for the development staff. So that was pretty well documented in the study. And sometimes projects were obviously rushed in to production with little to no QA. So again, not all projects, but the less testing done up front, obviously the higher cost on the back end is what the final outcome of this report was about. So that's not a rational trade-off, when you think about saving time, as opposed to the cost of the project. So modules with high defective rates are more expensive and time-consuming to deliver than error-prone modules or less error-prone modules. So it's been estimated to cost more than 4 times more to maintain a project that has, that's in this category of insufficient quality QA and testing in production. So as developers, we know that we can't detect everything or 100% of all the problems in development. After all, it's sometimes impossible to reproduce our production environments for testing to be accurate. So, and there are numerous other reasons that bugs are missed in QA and development. But what if we could improve our troubleshooting rate and do it much, much earlier? So ZenZone research, we researched our current customers, PHP customers, and discovered that developers and their teams spend at minimum 30% of their time, sometimes up to half of their time really working on production level maintenance issues. So wouldn't it be great if there was some way to reduce the time spent troubleshooting and getting back to developing new code. So introducing you to kind of today's agenda, what we're going to cover. Some of this may be old and information that you may already know, but I do promise that I'm going to have some tips here that will be new, especially towards the end of my presentation. I have a few new things to share that I think everyone will benefit from. But we're going to just start at a rudimentary level because we have all sorts of attendees today. We're just going to start with basic what types of PHP issues are out there and to be aware of. And then we're going to progress into some of the strategies used, things like error logging, how do we reproduce a problem, how do we do code tracing, and then I'm going to jump right into demo. So I've got a few slides, probably too many slides, so I'm going to rush through these really, really quickly because I really do want to go into my demo for everyone. So again, if you have any questions, if I rush through something too quickly, don't hesitate to type it into the chat window. So just a list of common PHP errors, categories of errors. And if you've done just 1 hour of PHP programming, you've already probably bumped into these immediately. So these should not be a surprise to anybody on the call. But the top two in red are the most important for developers. These two categories, which are the E_error and the E_warning type errors, they should be solved before bringing a project out into production. We shouldn't be seeing any of these kinds of errors. Now the rest of these on the list here, the notice or warning errors, they're not critical errors, but they could introduce problems. When you set your reporting level in your applications, it's good to really set it at the highest level for development. And so these are the kind of categories that we're reviewing right now. Obviously, parse time errors, there's something that need to be addressed. We're going to be looking at some of those very quickly. And also E-strict. It's the strictest level of error reporting. There's a lot of suggestions there, especially when you have older versions of PHP, like PHP 4 moving to 5. This will highlight a lot of places for you to modify your code and when you set it to that level. We're going to talk about the deprecated. So that kind of capability is an option in the PHP environment, and obviously user-generated events. I'm going to talk quickly about those. There's actually two different ways that you can have user-generated or custom events in the environment. Obviously using the E_user, or I should say there's a function that we're going to be talking about that'll allow us to generate E_user kind of triggered errors. Well, the function's right there, trigger underscore error. But we'll also talk about other capabilities that'll give us a lot more detail, a lot more capability to do reproduction of problems. And those were your most common programmatic type of problems. But there's also other categories that don't show up in log files and things like that. Obviously, logical mistakes in coding. When your code is not executing the way you expected it to. So those are definitely, it's a big category. The one underneath it is actually a huge category for probably a lot of people on the call today, which is really performance problems. So we're going to be demoing some of these today, tackling some performance problems. The final one on here, also a big category, security issues. That alone is probably an hour webinar, so I'm not going to really drill into that one at all. I invite you to go on to our pre-recorded webinars or training. But I just wanted to let you know that's also a really, really big category that we as developers kind of face. Okay, a little bit about best practices. So earlier, again, we talked about setting the error report levels and what gets displayed. So best practices, in a very simple way to get a little bit of visibility into where your problems are is obviously setting up these error reporting levels in your application. And you could do that as directives. You can also do it at runtime. At the bottom, you've got the error reporting function and in its set functions to allow you to set what level of reporting your application provides. Again, it is best practices in production not to display any errors. It's cleaner and you don't want to give hackers any more information to exploit your site. So turning the display off should be a best practice for any applications out there. You know, if you look at most open source apps out there, they've got an if statement at the beginning of all their modules to do this. It's either in debug mode or it's in production mode. So this is the if else statement for those two modes. So just a really quick example, you know, for the beginning PHP users out there. This is a quick. You can copy or type this into a PHP window and run this. And what you're going to see is you're going to see a warning on line number 4, undefined variable. You're going to see, I should say, a notice. You're going to see a warning about a divide by 0 on line number 4 also. You'll see another warning as well as a fatal error. So this is just an example of the type of reporting that you see when you run this, you know, these types of applications. So custom errors, we talked about them really quickly. It is available in PHP. There's a function called set error handler. It allows you to customize error handling of PHP. So for example, what you can do is you can send an email to the administration or the staff if a fatal error happens. But just note that when a fatal error does happen in PHP, it's still going to stop execution. So there's no way to bypass that. You're still gonna halt execution whenever there is a fatal error in PHP. You know, obviously you can log those errors instead of to screen. They can go to the error log, and there's directives in PHP INI to do that. All this is very, very well documented. The downside is there's really not a lot of information sometimes that will help you when you're logging. And as a developer, you spread throughout your application echo statements, you know, saving variables and things like that. Sometimes they're in the right place, and you're lucky enough, you know, when there is a problem to have the right information. But mostly, you know, there's a kind of detective process that you go through, or iterative process, where you keep putting more and more echo statements, trying to drill into the problem and getting more and more information about that. That's a typical way of using the log file and things like that. The other downside to the log file is there's a lot of information there, both from the PHP application and the web server and things like that. So it's hard to go through all this information and sort out, you know, what's the most important events to kind of tackle for, you know, for the current day or for each, you know, each developer in his role. So, you know, if there were better ways to handle the amount of information, you know, when there is a lot of logging going on, you know, tools to help you data mine what's in the event log and the error log become really, really important. And there's a bunch of applications out there that do that. There's a bunch of scanners. You know, I don't talk about them here, but there are open source utilities and scanners that'll actually go through all your log files, consolidate them, sort through them. But again, it's only as useful as what the developer has saved in the log file, and that's kind of the key there. If the developer hasn't thought of a particular error condition or thought about saving this particular object or variable into the log file for you know, for future debugging kind of capabilities, then you know, you've got to go through the process all over again and modify your code for the debugging. So definitely, you know, better ways of handling troubleshooting, especially when it comes to unforeseen scenarios, which are really the hardest types of problems that happen in production environments. So, you know, we're going to talk about those kinds of scenarios and what are the best, you know, best ways of architecting your application. So very common is Zen. This is a Zen framework example of logging, but this, instead of logging to a file, will log to the Firebug window. So it's a really quick example of how to, you know, get a visual list of what's happening or debug information. Typically very, very useful for environments where you have things like AJAX requests and things like that, where, you know, you need to get information both from the client and the server. So this was a really quick example of how you would implement that in Zend framework. But I'll have more examples for Zend framework coming up, but that was just a really quick one. Pinpointing problems with Zend Studio is also one of the key tools that developers use. And we're going to look at some of the capabilities that having Zend Studio in your back pocket, having it as part of your development arsenal, really gives you a lot quicker response, a lot better productivity to tackle some of these problems that we're talking about. So earlier we talked about eParse, and let me just click forward just a little bit. This is a zoom into one of the examples. We're in Zend Studio here, and you notice that this works in Zend Studio or PDT depending on what you're using, but it quickly identifies an eParse kind of error in your code faster without you having to go and execute the code and getting a error response back. So notice the red squiggly line and the red X on line number 10. So here, here's an object that obviously is incorrect, and this, visually allows you to quickly look through your code and find those obviously without having to completely go and execute. Is really detecting logical mistakes which can cause fatal errors. And again, look on line number 8. We've got a yellow squiggly, so we mistyped an object there. It's a misspelling. Sometimes these logical mistakes in the code could be in variable names, or sometimes we use the wrong case to capitalize within PHP. Even pluralizing. This is something that I've done in the past, and it's got me in trouble where I've used plural versions of a variable and non-plural versions and just forgot about the difference in the code, and that caused problems. So sometimes they're easy to spot, when it's not working. Sometimes they'll drive you crazy because PHP doesn't require you to declare a variable type for at the beginning of your program. So this is both a blessing, obviously, and a curse sometimes. So notice in this example, Zend Studio as well as PDT will automatically highlight those kind of scenarios for you. It also has debugging capabilities, and one of the key new things in 7.1 is really auto detect. So if you have a whole development solution that's installed with Zend Studio as well as Zend Server on your development box, it'll actually auto detect it, and it'll auto configure debugging and profiling for you. So certain types of problems in your code have to do with it not executing the way you expected it to, and how else do you kind of go through that, but actually using the debugger to single step and watch the variables as they're being set. This is one of the best ways to troubleshoot, and using both Zend Studio and Zend Server together, this works very, very easily. It's set up very, very quickly, and allows you to allows you to do breakpoints within your code, allows you to do conditional breakpoints, a lot of functionality here. Notice on the upper right-hand side, this window pane, as we're single stepping through the code, that's what the green line is. We're kind of at line number 8. It'll tell us what the variables have been set to prior in the application, and that's what that window is, the variable window to the top side. If you're interested in more detail, we've got 1-hour webinars that just go into how to debug it on Zend.com site. So I wanted to direct you to that as well. The biggest category of problems I think a lot of folks face is really performance problems. The page is slow, the application is slow, but you don't know why. So profiling is really one of the key things. And again, along with debugging, Zend Studio and Zend Server together, when they're installed on the same machine, developer's machine, auto-configure also the profiling capabilities. So, tackling performance problems and understanding where the bottlenecks are becomes far easier because you've got timings for each and every function and class execution within your request, your page request. So that's what you're seeing here. you'll see all the requests to render a page. It's telling you the total execution time as well as the duration. And you could drill into any of these functions. You know, let's say right now the bottleneck is in the front controller.php. You could drill in there and get full details of really what the front controller script was doing and timings for each and every call. So you'll see that as one of my demos today. Okay, so you know, when we're keeping tabs on PHP applications, it's often difficult to separate application errors from general PHP errors, and if you aggregate them in the same location as your web server errors, it becomes even harder. So PHP reporting doesn't provide a ton of context to figure out a problem. You know, we get some information. You know, we even get reporting on uncaught exceptions, but typically you'll only get some cryptic messages and, you know, what file and line it may have happened on. So that, you know, it is limited in many ways for, you know, some of the more sophisticated types of situations that we find ourselves in as developers. So some of the limitations include that you know, log files don't help with performance issues. Remember earlier I was talking about profiling inside of Zen Studio and Zen Server. That's definitely one way of tackling it, but log files won't help you there. You know, again, you have to do timings within your code when you echo that out, so it's really difficult to get good information from a log file to even tackle a performance issue. It really doesn't help with logical errors at all. So again, I showed you the debugger kind of capability earlier from Zen Studio. And does require, it's really difficult to reproduce, if not impossible to reproduce based on the information that is saved in the log file. So again, you know, it's really a narrow view. It does give you a view, you know, mostly application oriented. There's probably a lot of information that'll help about the logic of the application. Might not be as much help for some of the, you know, some of the errors that are happening, especially in a production environment when they become emergencies. So we're going to look at ways of improving this. One way is really deep level monitoring in our application, and that's something that I wanted to bring up as part of Zen Server. We have application monitoring that automatically monitors the complete application, not just individual lines, or you could think of them as kind of milestones in an application where the echo statements are, but it covers the complete application. So the categories that I'm talking about include things like PHP errors, including all of the categories that we introduced you to way in the beginning, failed functions, you know, functions that return that have failed or returned bad results, failed database queries, slow running functions or slow running database queries, things like that. So these are performance issues, slow requests that were executed. So that, you know, this could be a curl request, it could be a request going to the shell, it could be a request, SOAP request, so, or even a web request. You know, all of those kinds of requests are being monitored automatically without changing the code, you know, or making any more additional modifications to your PHP code. Also, we have things like memory. We're tracking memory, high memory consumption, and something really useful for the developer. You know, this is something I wish I had when I was working on some of my earlier projects, which is really memory and performance creep. It's a whole category that we're monitoring automatically within the monitoring of Zen Server. And the way it works in Zen Server, I wanted to kind of introduce you to that, is Zen Server installs a monitor it's an extension, it's a PHP extension, so it monitors at the language level. This is why it doesn't require the developer to add any special functions to his code. You're going to see me do a demo today of an open source app, Drupal. It's a very popular open source application out there. You folks, you know, many of you are probably using it today or familiar with it. I took it straight off the Drupal site, and I haven't modified the code at all. And what you're going to see is these types of categories are all being monitored, and it's giving me a lot more visibility into problems that are happening in my application, especially with applications that are designed by a big team or even open source, that have been generated by someone else's code. So, the performance problem, or maybe you've added a module, an extension to Drupal, that's really causing it to work poorly. It doesn't even have to be performance; it can just not be working correctly anymore. So all of that will be monitored. So it becomes a very critical tool for you. Looks like this is a quick screenshot. I'm going to do a demo, so I'm actually going to drill into this for you today. So I don't want to spend too much time on this slide. And one of the key things here is obviously getting to the root cause of a problem. So the quicker you can analyze a problem, the faster you can fix it. So that's one of the key goals of creating tools, this type of tool inside of Zen Server for the developer, is to give you much more productive tools to understand why problems happen, all the information to understand why that problem has happened anywhere in the application, because it covers the complete PHP application anywhere. Even if you add a third-party extension to Drupal or Joomla or Sugar CRM, even if you add that later on, it's still PHP code. The environment's still going to monitor it for bugs and problems later on in the project. So very extensive. And it also does allow you to proactively alert the staff. So if there is a critical failure or critical performance issue, you can also email or do something about that. You'll see a capability shortly called code tracing. But what we save as far as detail is things like, what was the URL request that caused the problem, what file was it in, what line was the problem in, what was the exact error message, how many times has it happened. And this is kind of a key thing, is for developers, it's really good, it's good to have a list of problems in a log file, but which of those errors are happening frequently, or which one should I focus on? It may not be the last one on my error file, appended to the error file list. It may be somewhere bubbled up somewhere higher that happened at 10 in the morning, or maybe it happened late at night because we were performing end of day process that just had a lot of critical errors.
Ed, could you just try and speak up on the phone a bit for us? We've had a few people ask you to speak louder.
Sure.
Thank you.
Sure. Is that better? Okay. I'll try to do that. And so there's a lot more information being saved to reproduce the problem, and that's kind of the key for root cause analysis. We need to save as much information, what the get information was that caused the problem, what was entered into the form, prior to this problem happening. Maybe the problem was caused by users typing in certain, a certain value in a form, and that's why it seems to be a random problem. Well, we're going to capture exactly what the user typed in as far as the post request. All the cookie information, all the server-side information is being saved for us to reproduce the problem and drill into that problem. So very sophisticated, a heck of a lot more than we developers usually save, because again, we try to save things that we expect will help us in that section of the code when we echo it out to the log file. But in our case with Zen Server, we're going to save all this information that will help you reproduce a problem, along with the backtrace. And you'll see me do this as part of my demo. So again, earlier, we talked a little bit about Zen Studio and how it can help with certain categories of problems. But when we are talking about reproducing a problem, this is really where the two products shine. Where Zen Studio, working together with Zen Server, allow you to click on a problem that's been captured, event that's been captured, let's say a performance problem, and then we could profile that specific performance problem. So that becomes a really, really powerful way for developers to cut the time in half or more, when they're dealing with issues that have been identified in QA, or they have been identified in usability testing and things like that. Again, the sooner we can get to a problem, the sooner we can identify that problem, the early on in development, the lower cost and faster the project gets out. That's really what those studies up front that I talked about have shown. And there are multiple studies out there. It's just one of the ones that I read about. So I'm going to show that as part of my demo today. PHP code production. We talked about this very, very quickly, but up front, when you do release your code to production, the best practice is to make sure that you've addressed all of the warnings under the e-warnings category as well as the e-errors category. They should all be addressed. So fatal problems as well as warnings that are being detected by the system. And Zen Server monitors all of these categories as part of the environment. And it also does it, I just wanted to make this clear in case it's not, it also does this in production, even when you set error reporting lower or off. Because Zen Server is installed as an extension, it gets much more information than is being exposed to the user or to the logging system because it is set up at that level. So, even though we do release code out that is error-free, why do we still run into issues in production? And this should be pretty obvious to the veterans out there. There are differences in the production environment, and because of those differences, the database has different values. The users obviously are typing in different things than user testing does when the user application. The load is very different in our production environment than testing usually. We could try using Load Runner or other stress testing tools to emulate real world, but nothing is the real world except the real world. So, so for a big category of problems, they'll only show up in a production environment, and usually when it's an emergency, as we all know. And obviously, there's Murphy's Law. So I don't need to talk about that. That's pretty self-explanatory. Okay, reproducing an issue so is not always possible, right? So it depends on sessions, database state, has dependencies on server load. Replaying certain requests become very risky. Okay, and this is a big one actually. So we talked about reproduction capabilities with our environment. But sometimes we can't reproduce a scenario that we've captured, right? We can't. For example, if we had a problem with someone's credit card transaction in our shopping cart, we don't want to reproduce that because it's going to deduct from our inventory. It's going to, recharge the credit card. And this is why we have dummy guests and dummy inventory in our applications in order to try to reproduce, scenarios. But again, even with the dummy data, it doesn't always 100% allow us to reproduce what we're seeing. So code tracing is one of those key features of Zen Server that gives us the analysis and root cause when problems are impossible to reproduce, or the consequences, like I talked about, are damaging when we try to reproduce it. So this we've introduced in Zen Server 5.0. This is the main benefit for utilizing code tracing capabilities in 5 is to reproduce the exact, not to reproduce, but to get visibility into the exact problem that's happened in the application state and what and under the server load in production and things like that. So this capability I'm going to show you, we've released it in 5. It allows us to do Zen Server root cause analysis capability. It's taken it to a whole new level by introducing this kind of capability in the product. Code tracing captures PHP application execution both in production and in test lab environments. Definitely useful for development and QA as well. This allows a developer to drill into problems that have happened and look at the workflow and the variable information in a way just like debugging, but with a web interface. So you'll see me as part of my demo kind of go into this. So as a result, there's a dramatic decrease in time consumed by root cause analysis. We like to call this the black box feature of Zen Server, but it's for PHP applications instead of airplanes. So as you know, when a plane has a problem, even when it crashes, that's when you hear about the black box. Usually the mechanics go to the black box to find out, what was happening to the plane. What altitude, what degree were the flaps at. It's really monitoring all sorts of different areas within the airplane. Well, if you imagine a black box built into your PHP application, so when a certain events happen, a certain category of events happen, let's say performance bottleneck, for example, if we activate it for performance detection, it'll capture all the information for us to drill into that performance problem, into the exact production problem. So we're not reproducing it. We're actually drilling into the problem that happened to our user. So that's a very key idea and capability for developers to have this sort of information available. This is something that they never had in the past. So to respond to emergency situations, especially in production, have this sort of detail available to you becomes kind of a critical thing to address service level agreements and things like quick response to emergency situations. So again, you're going to see me do a demo of this in a few minutes. The web interface to it. Earlier, I talked about reproducing in Zen Studio. So Zen Studio is the client. Code tracing has a web interface. Actually, it's Flash enabled. So we use a very rich Flash interface. And I want you to notice a few key columns here. So this is a flow of a particular problem. It's a dump of a performance issue. And what you're seeing in this wiki example is two columns I want you to notice is memory usage as well as time. There's a column here, time, memory usage. And the reason I'm highlighting those two right now is those are two key columns of information, especially memory usage. Knowing how much memory your PHP application is utilizing is really difficult to do today. Often you run into problems with your application. They seem random problems, but they're related to running out, your application really running out of memory and things like that. So you can see here, we're keeping track, a running track of how much memory our request is taking up all the way, and we can drill into the longest running memory. Where are we taking up too much memory, and that's way down in output page, set page title down here. Or we can also do performance, and that's what the first column with time is all about. We could drill into any of the functions there that are taking the most time, and as we keep drilling in, we get information. So you see in green, right underneath the blue line, there's something that was returned. That's a value that was returned from running that function or class request. So there's a lot of information here to start debugging. I'm actually going to show an example inside of Drupal, a performance example. It'll definitely give you guys a good idea of how this is being used in an environment. So code tracing can be used in several ways. It could be automatically turned on, so every time a certain category, again, we have 22 categories of problems in Zen Server. So every time a certain category of problems occur in my application, it could generate a code trace, detailed code trace of that problem. So example, you're going to see me turn on code tracing for performance bottlenecks. I could turn it, or I could turn code tracing on for memory issues. You'll see how easy it is to do that. Secondarily, we do have a screen that allows you to manually enter a request. So you can do on the fly, if you're developing an application and you're noticing something, you can go into the manual method, submit a request, and it'll do a complete code trace of that request. Again, very useful for development. Also wanted to mention that Zen framework takes great advantage of this environment, monitoring environment in Zen Server. So some of you may be using the Zen Log Writer. There's a new capability that was added recently called the Zen Log Writer Zen Monitor. And what that'll do is if there is a Zen server installed in the background, it'll start to save much greater detail about the application to reproduce the problem. So down on the bottom, you're seeing some Zen framework code here, where we're instantiating the Zen monitor capability, and then we're sending in some application and some custom variables that we want to log. So not just standard variables like I mentioned before, which included post, get variables, cookie variables, but we can also have specific variables in the application that may not be part of the request. Okay, things like here we have the request variable and the e variable. Those are not part of a function call or something like that, but we can still log them somewhere in there. Again, this logging is not required inside of Zen Framework in order to monitor the application by the 22 categories that are automatic and defaulted. So I wanted to make that clear. There are 22 different categories that we're going to monitor a Zen Framework application or any application. Again, I'm using Drupal today. It's going to monitor that without adding any special coding. But if you want to create your own category inside of Zen Server, you can, and you can save additional information. So here's an example of how to do that. And this is what it looks like. You'll then see the event. It'll be a custom event. That's what you see on top here. Custom event inside of the monitoring, and the variables are saved and displayed under the custom tab for an event. And you notice on the bottom we have debug this event, profile this event, so we have all the capabilities to reproduce this problem if we want to inside of Zen Studio. So a lot of power. The whole goal of enabling is really to allow code tracing to reduce our root cause analysis time, and that's what you're seeing here. So, with the earlier, good methods, they're not the best, but they're good methods of logging. Still there's a lot of time being spent to analyze code. With what I'm about to show you in demo, we reduce the root cause analysis. Typically by 50% the time to identify problems, understand where those problems are, and then obviously it makes it easier to fix it. So it makes you more productive. As a developer, you'll be spending less time in maintenance. Again, if we can cut your maintenance time in half, that's a great goal. It'll allow you to be more productive, develop code, which is really what we developers love to do anyway, develop new code and not maintain buggy code. So let's go into a demo. Okay. So I'm logged in to Zen Server. I've already logged in, and this is the first screen that you see. And if you folks want to follow along after my webinar, feel free to go onto the Zen.com site. I want to make that clear before I jump into this. Go onto the Zen.com site, download Zen Server. There's a 30-day eval of what you see here. Once the license expires, this reverts to Community Edition. So the product, there's no downside in downloading the full product. You'll just get extra capabilities. And it's still useful even when the license expires. So I just wanted to make sure I told everyone, basically what to do in order to follow along after the webinar. And again, it's on the Zen.com site. This is Zen Server. This is the beta version. This is 5.0. 4.0 is GA. 5.0 is in beta. You can download either one depending on your needs. So I'm running 5.0 here. Runs on Windows, Linux, and the Community Edition runs on Macintosh. Okay. So what you're seeing here is in the middle is a screen of events. And I'm using open source Drupal. This is, again, straight off the Drupal site. And what I'm doing is, I haven't modified the code at all. This is straight off the Drupal site. All I've done is I've added content to this. Okay, so I have two reports as menus. I've got a top 10 and a year-to-date report. And they're performing very slowly. If you see on the bottom here of my Mozilla, I've got a plugin called Time to Live. It basically gives me the time that it takes to render this page. It's about 14 seconds, so it's unacceptable. This is definitely one of the, it's a poor performing area in my application. So I don't know why it's performing poorly. I didn't design Drupal. I didn't design this page or the content here. But I'm going to go back into Zen Server. I'm going to redraw the page. I'm going to redraw in the top event, you should see, is the request that I just did. So here it is. That's the request of the report. It's a report for Node 4. And notice that all the get parameters, there was no post parameter. There wasn't a form that I filled in, but all the cookie variables that were in effect, as well as all the server-side variables, all of those were stored as part of this event, this performance problem. And again, if there was a syntactical problem, if there was a memory issue problem, there'd be a lot more detail here for me to reproduce those kinds of problems and drill into those. But this one in particular that I'm working on is a performance issue. The event up here is severely slow request. Okay, that's happened in my application. And right now you should notice to the right-hand side, I'm also tracking how often this problem has happened. This is a fairly new request, but you'll see as I go through my demo, there's other requests that have been happening frequently, so it lets me trend. You'll notice that we consolidate events, the same event that's happening in the same piece of code, together. So you don't have a huge, long, unwieldy list, an event log. You actually have a nice consolidated list. And you can focus your efforts really on the events that happen most often, events that you need to troubleshoot because they're very, very common in your environment, in your production environment, or in your QA environment, testing environment. So in this case, I have a performance issue, and there's several things I can do. Okay, and that's really what these buttons are all about here. I can profile this, and with ZenStudio installed, I can click Profile. This will communicate to my ZenStudio as part of my troubleshooting. It'll ask me, do I want to go into profiling mode? And what it's going to do is it's going to drill in, and it's going to showcase the next level of detail. Okay, so I know the page was slow. It's telling me that the request, when I re-executed this request, this time it took 12.5 seconds to render the page. It took 83 files to render this, and it's telling me really what the performance breakup is in the scripts. So 40% of the time was spent in PHP modules on Drupal, 34% of the time in the Bootstrap include file, and the rest is kind of negligible. So let's drill in more, find out where this performance problem is. I go into the next level of detail. It's called execution statistics. And what I can do is I can sort by the time that the functions were called. And it's this own time. This is a column that measures how much time that specific function call executed. And I can sort it, and I could find out that in this example, the two areas that those two areas that were highlighted in the pie chart, it was an eval statement, a PHP eval statement, and a Drupal load statement. Those were the two. The Drupal load was called 40 times and took 3 seconds and change, and the eval took almost 5 seconds. So the eval is the worst performing culprit here. If I double click on this, it'll bring up the code in Drupal, and it'll show me exactly where in my application the problem is. So this is the problem. It's a print eval, and if you're familiar with the eval statement, you know that it's notoriously poor performer, especially if the variable, the code variable there, has a lot of PHP code. It actually executes PHP code inside a variable. And if you know Drupal at all, one of the capabilities of Drupal is to type in PHP code right in the content. So people could be writing all sorts of bad PHP code and publishing it as a blog and things like that. And this is what will happen to your PHP site. Well, in a matter of a few seconds, I was able to drill in, find out it's an eval statement, find out exactly what page that problem was on, and tackle the problem. Inside a Zen server, and I'm not going to do this today, but there are several ways to fix this problem. So there's more to Zen server than just finding and troubleshooting. There's also a whole category of fixing these kinds of performance bottlenecks. So just really quickly, you can go on our website, look for our webinars that we have for performance optimization and tuning, and you'll see examples of how you can use Zen server's API to do caching here, or to do a full page cache, so we can improve the performance. Again, I don't have the time to go into that level of detail. I wanted everybody to know there's more to what you're seeing than just the troubleshooting part. There's also the part that fixes problems like this, and that's a big part of what Zen Server, and a complete solution offers you. So let's go back. I basically found one way of doing this, but let's say we're in a production environment, okay, and our request can't be reproduced. So let me go back in here and notice I also did a code trace for this. I don't know if you noticed that, but there's an extra button up here on top called Show Code Trace. So actually the detail for this has already been captured. So if this was a production level issue, there was no need for me to reproduce this. So if it was a shopping cart transaction, I don't have to replay the shopping cart transaction to follow the flow. Instead, I can just go straight into the session, the trace, the code trace of that session, and that's what I'm doing here. And what I'm going to do is I'm going to go through and I'm going to follow the worst performing function call. So basically what I'm going to do is I'm going to follow the highest value on the time column and percent column. And this allows me to drill in to my application, my production application. And notice that it kind of highlights the worst performing calls, basically in bold. So it's kind of easy to keep drilling. So in a few seconds of a production level issue, I'm drilling in, and I basically found, keep drilling, still another level. Almost there, okay. So there we go. All right. So this is it. This is the end of my tree. This is as much as I can drill into this, the same performance issue that I just reproduced. But now I'm looking at the actual production runtime of this problem, and it's telling me here that the problem again was in the eval statement. I saw that earlier with the profile, and it's also telling me what the call was. In other words, what the value was that was sent to the eval statement, and why it was slow. So I can see here that there's actually a really big PHP program, 282,000 bytes. There's a PHP program that's executing via this eval statement and it's executing very, very slowly. So again, very quickly I can decide to go to line 605 in the function and basically cache it, and basically cache that value to fix the problem, or I could obviously delete the content. So those are all, definitely viable ways of kind of tackling this problem. All right, so I know I actually ran right up until the time that I had, which is good. But I briefly introduced and did a quick demo of one particular performance problem. I wanted to let everyone know before we go into questions that there is a whole category, there's a whole section under Zen Server. It's under Zen Server, Rules Management, and this is really the default rules. So all the different categories of problems that we're going to be monitoring. Any application running here. So I could download Joomla, I could download Sugar CRM, I could download MediaWiki, and all of them on my server will be monitored for all of these categories, for PHP errors, for fatal errors, any custom events that I decide to add. There are none in all of these examples. Things like high memory usage, so memory problems are going to be captured here. And all of these, and I'm gonna drill into one of these to show you how to activate it, because I know a lot of you folks probably have questions. Well, how do I activate code tracing automatically? So I'm going to show you how to do that. So if I go to the category severely slow request execution, so this is the event. And the way this works, and the reason developers don't need to change their code, is because at the engine level of PHP, I have a trigger here that says any script that runs more than 2 seconds, or 2,000 milliseconds. So anything running over 2 seconds, save it. Save that as a problem. It's definitely a performance issue. So anything under that is not going to be captured because I don't consider that a performance problem. And classify that problem as a critical problem. And when the problem is classified, send an email to me. Okay, it's sending an email to me, plus do a trace of that. So you can always add more people, and you can add traces to any of the 22 categories that you saw earlier on the list. And again, those are all defaulted categories. Obviously, you can adjust this trigger to whatever makes sense for your business. Usually 2 seconds is a pretty general rule, pretty good rule. And once you set this up, you will now be able to trace. Just like I showed you, trace the detail of performance problems. You can do the same thing for memory. You can drill into the memory one, set what you set the value of what you think is too high of a threshold, and what a script, when to capture a script if it's using too much memory, for example. So you would set the memory value up here under that category, and also you would add, tracing if you want. So I did the same thing here. I've got an example of a memory issue problem. All right, since that's our hour, we're exactly at the hour. I just wanted to grab questions for the next 5 minutes. Any questions we don't get to, what I'm going to do is I'm going to post those on our bulletin board. But if I can also switch over, I'm going to quickly switch over to slides again. Just give me a second. Where you can get this, what you should get. So definitely go onto the Zen.com site. You can download eval versions of Zen Server, Zen Studio, and remember, even if the license expires for Zen Server, you still get the community capabilities, and that'll be in effect for you. So it's definitely much, much better. It's a superset of PHP, open source PHP. You'll definitely find that to be true. There's a lot of videos, a lot more than I covered today. Even in troubleshooting, there's a lot more that we discussed on the webinars on our website. So I welcome you to look at some of those. It's under pre-recorded webinars, and even under the product pages, there's a bunch of videos. And finally, there's a really, really good white paper that I wanted you guys to be aware of. It's called Code Tracing White Paper. So if you want to do this back in your office, go to our website, zen.com, click the resources menu, click white papers, and there's a white paper there called Troubleshooting PHP Issues with Code Tracing. So that'll go through details. I definitely gave you all the information of how to set up code tracing today, what it looks like, how it could be useful. So with that, I'm going to jump into QA. Will app-level monitoring work with custom, non-Zen framework PHP? Of course, yes. So hopefully I repeated that a lot, but if folks have questions, everything I showed will work with non-Zen framework applications, and my demo today used Drupal, which is a non-Zen framework app. So any PHP application will get these kind of capabilities, all of these kind of capabilities. So it's not specific to Zen framework at all. It is specific to PHP 5, though, so this is all PHP 5 related. About the code trace, how much code trace may decrease performance on dev server? Okay, code trace is doing extra work, okay, but there are two things that I want everyone to be aware of for performance reasons. One, when you do install Zen Server on your systems, it installs a number of capabilities to improve performance over the standard open source PHP. It's called bytecode acceleration, and it's got caching built in. So even though you're doing this sort of monitoring, and it is extra work, saving extra information to disk, you probably won't see any performance degradation because of the bytecode accelerator. We do ship the fastest bytecode accelerator for PHP inside of Zen Server. So that definitely alleviates any of the extra monitoring work. If you do, there are options to trigger this deep monitoring, this code tracing capability when an event happens. So it's for a certain amount of time. That is part of the functionalities. So remember I talked about automatic. You can turn on code tracing. There's also a value to turn it on it's almost like a just-in-time. So when the event happens the first time, it turns on monitoring for, let's say, 10 minutes for that event type. And it'll only be in effect for 10 minutes and then shut itself off. So for performance and production, heavy loaded production environments, again, you have to be at the 95 percentile CPU as far as load. You'll probably set up that sort of environment. Anyone that has more headroom than that, you can set it up to be basically this just-in-time kind of capability, and it'll only do it for a short period of time, but still saves you a heck of a lot of time when you do have an emergency kind of situation. So realize that there is a benefit to having this deep level monitoring in a production environment. How does Zen Server clear out old log files to stop filling up the hard disk? We actually have a cron job that can be run that'll clean up the environment. So that's something. It's called a watchdog. We have it for many of our processes. So it's something that can be set up. Okay, there's a question here. Do you need to buy multiple copies of full Zen Server for each environment you have that you want to monitor? Okay, so if you are running multiple applications as vhosts on your server, then you're only running one Zen Server. Okay, Zen Server will monitor on any PHP application running under an Apache process. So for each Apache process, you basically have installed a Zen Server. So if you have multiple servers, then you're going to install multiple Zen servers. Zen Server is architected, and I wanted to make this clear. The architecture is just like open source PHP. It's not a separate server. It doesn't replace Apache. We still use Apache. On Windows, we still use IIS. It's still installed as a Apache module in Linux. And on IIS, it's a fast CGI. So just same architecture as open source PHP. What we've done is we've extended the environment. It's a superset of open source PHP that we develop. Our engineers develop both. But it's a superset of open source PHP by adding new extensions, like the monitoring extension I showed you, like the debugger and things like that, bytecode cacher. Those are all PHP extensions that were added to the environment. So there's, if you're interested in drilling into more detail, again, I focused on Zen Server specifically for troubleshooting today in this 1 hour. But there certainly is a heck of a lot more to Zen Server than I introduced you to. Definitely welcome you to take a look at the webinar that does a general overview of Zen Server 5. That'll be our latest version of it. So definitely take a look at that when you have a chance. Can Server handle applications on cloud? Sure it can. Yes, we have an image. We have an AMI image on EC2. Very cloud friendly, and it's only getting more cloud friendly. And if you folks are not familiar, we've also announced a partnership with all of the major, almost all of the major cloud providers to create an API for PHP. So this is not related to Zen Server, or kind of related to Zen Server, but it's a developer's API called Simple Cloud. Allows you to create PHP applications that can run on internal virtualized systems without changing the code, as well as any of the cloud services out there. So Amazon's, Microsoft's, Rackspace, et cetera. So just like the operating system, we work across Linux and Windows the same way. Think of this technology and the API allowing you to create PHP applications that work on all clouds. So you develop one application using the cloud services, and it can run inside the company on virtualized systems as well as any of the cloud services. So, yep, runs well, and Zen Server definitely runs in that environment. And you could have access to the AMI image. It's already published publicly on Amazon. So, if you can't find it, just post a quick message up on the Zen forums, and we'll have one of our guys direct you to the AMI image of it if you're on Amazon. Will Zen Server prevent flooding your inbox with emails? There is so the answer is mostly yes. I've never experienced a flooding, mainly because we have what's called event bursts protection. So when there's a burst of the same same event, problem event happening, we're not going to capture all of it. We assume that capturing the first 10 or 20 events in the event storm, in a sense, has enough information to reproduce the problem and figure the problem out. And what we're going to start to do is count that this problem kept happening in the same, minute or 2 minutes, while the storm is going on. But we're not going to keep logging, thousands of requests of the same request. So because we don't log thousands of the same requests, and we're just counting, you're not going to get thousands of emails. So yeah, if you have another, more detailed follow-up than that, just definitely post it on the forum. Okay, that's it for time. I have actually covered all the questions I saw. Actually, half the questions. Sorry, I didn't see this other section. I covered half the questions I had. There are 3 more. What I'm going to do is I'm going to take the other 3 and any other ones that you folks have after this event. Feel free to post it up on the Zen forum. I'll keep an eye out and answer the questions for you there as well. Thanks a lot for joining us, and I know we got another exciting webinar, being planned by Andrea. Thanks a lot, folks.